Okay, so the first questions we're going to talk about for 2.1 are in this set. This says using the standard form to graph the parabola. Okay, so why did I pause that? I had to flip to page 117 to grab the standard form. And the book is using the following definition. So first of all, you don't have to feel bad if you don't know what the standard form is. That's pretty obvious because every book has a different standard form. Okay, so this is the book's definition of standard form, and what they mean by standard form is they're using a series of shifting and stretching. So first you're going to shift the standard parabola, and then you're going to stretch it, and then you're going to shift it again. So this is the H tells you the right-left shift, and then this gives you the stretch in this direction, and then this gives you the lift in this direction. Okay, that's what the book is meaning when they say standard parabola form. Okay, so that's the first thing, is to get the definition right. And then it says identify the vertex, axis of symmetry, and x-intercepts. Well, that's kind of annoying because these shifts that you find are not going to give you the x-intercept. You'll be able to find the y-intercept pretty easily, but not the x-intercept. So that means factor. It means first of all, factor. So it means factor and do this thing to it, where it's essentially a completing the square exercise. Okay, so it's a two-part exercise that looks very innocent. It could be very nasty. But the worst that you're going to have to do is pull out the quadratic formula. So let's pull out one of these questions. I'll pull out a number after this range so that you can have the fun of doing these problems yourself. So how about number... see, you should be glad I cut it there because actually there's a whole bunch with fractions. I don't want to deal with fractions either, though. So there's a problem, number 30. It's minus x squared minus 4x plus 1. But I'm just going to change that by a negative. Okay, so I'm going to use a problem that's similar to the ones that you would be given. So how do we do this? So first of all, the factor question. How do we factor this dude? I don't know. This looks kind of nasty. So I'm not going to factor it. I'm going to use the formula. And that's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So when you do that formula, minus 4ac, you're looking here and here for how many negatives you've got. And we have one negative, so it turns the negative in the formula into a positive. So what we have is negative 4 plus or minus square root of 20, and 20 is 5 times 4. And normally I wouldn't care, but we really, really need that 20 to be busted up because that 4 comes out and cancels this 2 down here. Otherwise, we're going to have a big mess on our hands. Okay, so this is actually going to be negative 2 plus square root of 5 and negative 2 minus square root of 5. So luckily, this part of the problem where you have to find the x-intercepts is completely independent from the rest of what we need to do. Okay? The rest of what we need to do is to deal with x squared plus 4x, and then the minus 1 gets held off to the side for a while. Okay? And then what we do is we just factor this, but we get a free wish. We get a free wish to add or subtract anything in here as long as we balance it outside. And we do it so that it makes our life easy. And that's what completing the square is about. You can think of completing the square geometrically or algebraically. But this is what it does, okay? So we can do x squared plus 4x. And if I just, the easy way to do this algebraically is just take 4 divided by 2 and then square it. And that is 2 squared, which is 4, Okay, and then this goes up here, but you have to balance it with a -4. Okay, so what number did we take to begin with? We took this 4 from here. We divide by 2 and square it. So that's the algebraic way to think about completing the square. It's pretty easy. And then we just go ahead and factor this guy. It's you put the 4 divided by 2 goes here, which is 2. Okay, so this 4 divided by 2, this piece, before you square it, goes down there. Okay, now these pieces become -5. Alright, so again, you're looking at this term here. You divide by 2 and square it, and it goes here. You divide by 2 and don't square it, and it goes there. Very, very simple. That doesn't give you the rationale for why it works, but it just gives you the steps you need to take to do the exercise, and that will be good enough for all these exercises. So what did the question say? It says, identify the vertex. Well, the vertex is this thing we just found. That's easy. But you have to put a negative in front of it. Vertex is -2. It's the thing that causes this term to be 0. That's the x component of the vertex. What's the y component of the vertex, which is annoying. So you would have to say y of -2 is -2 squared plus 4 times -2, which is -8, and -1, which is -5. So the vertex is -2, -5. Details, details, details. Okay. Alright, so that's the vertex, and they want to know the axis of symmetry. That's easy. The axis of symmetry is always going to be an x equals, and it's just going to be this guy. So if you have the vertex, the axis of symmetry is really a cinch. What else do they ask? It says, and x-intercepts. So there you go. There's the whole question. Okay, so let me do another one. X squared plus 34x. Again, yours should be easier than this. Plus 289. This is one of the higher number of questions in that same set. Okay, so what are the x-intercepts? I don't know. What are the factors of 289? I hope that one of the factors is either a 34 or maybe a 17, possibly. Maybe 289 is 17 squared. Maybe we're going to get lucky. And there you go. 289 is 17 squared. So we're going to get really lucky here. Woohoo! X is equal to -17 is a double root or a double x-intercept. Okay, so we took care of that problem. We got lucky. If we hadn't known that or hadn't figured that out, we'd have to say -b plus or minus the square root of b squared minus 4ac all over 2a. And what a pain, because this whole thing would end up being 0. And then you get -34 over 2. So it would work out anyway. But that would be what would happen if you didn't notice that 17 squared is 289. Which is okay. It's okay if that happens. Okay, next question is, how do we complete this square? Well, we just kind of got lucky again, because that actually does complete the square, and then it's plus 0. Okay, so what that means is the vertex is -17, and it's actually already an x-intercept, so we're lucky. And the axis is x is equal to -17. So we've got our roots and our vertex and our axis. And so that shows you that sometimes a problem that looks really scary is actually really easy. And I'm staring at the book, and there's at least one exercise that works out that easily in your homework also. So those are good examples. Okay. I'm pretty sure I cut some of these problems out of your homework set. So refer to Blackboard and see if you have to do them before you do them, but I'm going to go over them anyway. So this problem says, what is the height of the diver? They're claiming that the path of the diver looks like this. They have a great little picture of somebody diving off of a board. Okay, and they say there's units in it. And this is the F of x is the height in feet, x is the horizontal distance from the diving board. What is the maximum height of the diver? All they're just asking for is the vertex. Vertex y value, in fact, because if they wanted to know the x at which this vertex occurred, they would say, what distance from the board does this occur? They don't say that. They say, what's the maximum height? And so all you have to do is figure this out. I'm kind of annoyed by these 9s. That's just annoying to me. So I want to find the vertex anyway. And that doesn't involve finding roots. We just need minus b over 2a. And then, oh wow, that's not too bad because minus b over 2a, I can just ignore those 9s because they're not going to matter. What's 48 divided by 8? Should be 6. Okay, so x is 6, and so we need the y value. So we need f of 6 equals, and you can figure it out. It's going to be times 36 here, plus 24 over 9 times 6. I have no idea what this is, but you guys can figure that out yourself. Okay. A rancher has 200 feet of fencing to enclose 2 rectangular areas, and the picture specifically wants you to do this. Total fencing is equal to 200. And this is setting you up for calculus. So in calculus, you get to find the maximum area of the pens, and it's just going to be 2 squares, just like you think it is, so it's not a big deal. Well, it might not be 2 squares. It might be some variant. It might be like rectangles with sides 2-to-1 ratio or something like that. But anyway, it always comes out to be a nice round number. But for example, let's see, this distance has to be x, 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 and this is y, y, y. So the total fencing is going to be like 3y plus 4x, but the total area is going to be 2x times y. That's the kind of thing you're looking for. Construct a table showing possible values of x and the corresponding areas of the corral. Oh yeah, we have to have total fencing as just equal to f. And so what you do is you're going to say something like 200 is equal to 3y plus 4x. And we want to know what the like all the different possible combinations that would be, like, not all possible combinations, but maybe x's 10, 20, 30, you know, things that make sense. And then you're going to try to estimate what the area is. So they really want you to do this hands-on thing. Yeah, so let's see. We should probably solve for y because the book labels side x in exactly the same way I have. Funny that. That didn't happen on purpose. Okay, there we go. So that's what y has to be. So the total fencing then is equal to 3y plus 4x. And guess what? This is completely ludicrous. This doesn't help anybody because it just says fencing equals 200, so that doesn't help us. Okay, so what they really want you to do then is they want you to say area is equal to 2x times 200 minus 4x over 3. There we go. That's the thing they want you to investigate. I'm going to just make some space here. So they want you to try x versus A. See, if it were me, I'd say make a table of X's and Y's first, and then just multiply them and times 2. I mean, this would be, the book says to do this. So you probably want to try something like 10, 20, 30, 40, 50. Yeah, it can't go higher than 50. How about those 4 values? Try those 4 values, plug them into here, and figure out what the area is. And that's good enough. Okay? That's a pretty good exercise. Okay. What about question 83? Oh, by the way, 84 is definitely off the list. You do not have to do that one. I'm pretty sure I canned that question. It's a really fun question, but it's not something you do when you've had 2 days cut off by snow. Small theater has a seating capacity, so 83 seating is 2,000. The ticket price is 20. Attendance, I don't know why they're telling us seating and attendance. Usually they only give us one of those. For each $1 decrease in price, attendance increases. If price goes down $1, attendance goes up by 100. Okay, this is why, because the attendance and the price are tied in this way. Right, the revenue of the theater is a function of ticket price. How annoying. Okay, but this is a great question. Okay, so we have attendance is a function of ticket price. You would need to actually find out the most important part first, which is the attendance versus price is actually a line. And when its attendance is 1,500, they said price is 20. So the key part of this question is to realize that we have to make a line. And it says if the price goes down by $1, attendance goes up. Okay, and then if it goes down again, it goes up again. So what's that slope, right? So what we're going to do is we're going to say price is like X and attendance is like Y. You could do it the other way around. The whole analysis will work if you do it the other way around, but this makes it easier. So change in Y over change in X, or if you prefer Y2 minus Y1 over X2 minus X1 is going to be 100, but it's going to be negative, right? And then we want to find this equation. Y is equal to mx plus b. We don't know what b is. We're going to actually solve for an important physical quantity. So in this case, y is 1,500 is equal to minus 2,000. That's some seating happening. Okay, so we have 35,000 equals b, so 3,500 minus 100x. But we can't actually seat 3,500. But that's still going to give us, theoretically, it means if we had a larger auditorium, we could sit 3,500. Okay? So we know this is the cap on seating. So this is kind of a subtle question. So it wants a revenue. Revenue is equal to the price. So price is X. Price is X times attendance. And then attendance is 3,500 minus 100x. Okay, but remember, this is kind of bogus. It's a bogus start point. But the formula works, and you can still use it to maximize revenue and do stuff like that. So to maximize revenue, this thing turns out to be a parabola. I don't think they ask you to maximize revenue. Yep, I'm sorry, they do ask you to maximize revenue. So let's go ahead and do that. But we have to just double check that it's got the right amount of seating. Okay, so revenue is equal to 3,500 minus 100 squared plus 0. This is the A value, and this is the B value for, we need to find the vertex. So minus B over 2A well, if it were 30, it'd be 15. And 5 gives you 2.5 more, so it's like 17.5. Does this still work? Check. Capacity. Condition. Okay, so 3,500 minus 100 x, but x is going to be 17.5. And so it's going to be 3,500 Okay, so we are within capacity. The capacity is 2,000, so we're okay. Okay, so does it say to maximize the revenue? No, it says at what ticket price will we and then it says what is the maximum revenue. Okay, so the ticket price you want to set, you're going to set it at $17.50. Okay, that's great. And then we want to know what's the revenue. Okay, so the revenue is $17.50 times, we already calculated this actually. This was half of 3,500. What was that? I forgot what it was. Once you've done a couple of these problems, it's actually this vertex always ends up being at half this value. I mean, anyway, you'll recognize that. 1750 times 17.5 is 3625. Okay, there we go. So there's your max revenue. Okay, so I actually did the whole problem for you. All you have to do is watch the video and copy down the answer for that one.